Okay, I guess this is probably working. Well, this is my screencast for the qualification round of the Google Code Jam, which is not a round that has time pressure, so I've just chosen to do it at a particular time. And, wow, good timing, Carnage. Yeah, so we're living in interesting times, and I don't know, life is pretty bad right now, but that hasn't stopped the Google Code Jam from running, so it might stop the finals from running, but we'll see. It's also delayed the ACM World Finals. Sorry, the ICPC World Finals. It's no longer called the ACM. So yeah. Anyway, if you want to find out whether a crusty, aging 41-year-old who's way out of practice can still code, then tune in. I guess there aren't too many people who do full screencasts of their contests. There are a couple who are much better than me, but I don't know. You're probably starved for options. So here we go. Let's see how it goes. Now the qualification rounds are usually, let's see. So, 5 problems. Okay, so it looks like 3 problems that are going to be pretty easy, and then they've got 2 tough problems. Normally they just have 1 tough problem. You really don't have to work on the tough problems in order to get past the qualification round, but of course you might as well for the practice, right? So yeah, let's give it a try. First contest problem I've solved in a while, so let's see how this goes. All right, so we've got matrices. Okay, so one thing we're not checking is whether the numbers are between 1 and n. So that is a condition of the input. And there's only 1 test set, so they're not even doing they're not even doing a hidden test set. All right. What should I call this? Vestigium. Well, with my extensive years of contest practice, I think I might be able to see how to check whether there are repeated values in a matrix. All right. Of course, I might not be able to type. Okay, and so I just have to separately count. Yeah, okay. Pretty straightforward. Yeah. Oops, got those backwards. This is more like a do you know how to code test. Yes, I know how to code. Yeah, just for funsies, let's do. This won't work for the others, for the rows, but whatever. So this is a row, right? Yeah. All right. Okay. Oops. It is a square matrix. Oops. Yes, I am running on Windows. All right, well, somehow I've managed to successfully get that on the first try. Boo, that was a tough one. This is a good sign. I'm going to win this Google Code Jam. That's odd. Wait, it's not letting me upload. Oh, just select language. I really miss the old Google Code Jam interface. I don't think it's an improvement. What? No, it's... Am I in the right directory? Oh, I'm probably not in the right directory. Oops. Good start. Okay. Did I mess anything else up in their weird format? Okay, well, at least the feedback is fairly fast. So, woohoo! I got one! Aren't you proud of me? Everybody's very proud of me. I should have some applause. I should have an applause sound effect or something. Okay, let's move on to something that's a real... Well, this probably still isn't a real problem, but... Nesting depth. Tldr at the very start of the problem. Nice. Okay, so we don't have to deal with multi-digit numbers. So that's 2 and 2, not 22. All right, this seems pretty simple. The minimum length, you'd think that would be a tough criterion, but I think for something like this, you're just greedily adding parentheses until it works. I'm pretty sure that that'll just work. So, yeah. Like, you'll scan here, you'll get to this 1, you'll say, oh, I'm not at a nesting depth of 1, so I need to add some parentheses. And then, you might need to add closing parentheses if it's too high, or opening parentheses if it's too low, et cetera, et cetera. Yeah, and they're not showing, none of these test cases are at all hard, so they're not actually showing interesting test cases, but whatever, there aren't all that many interesting test cases. What's this called? Nesting. Oh my god. Fine. Nesting. Normally I set up a little template, but I haven't bothered since this is just the qualification round. Okay, so length of S is to 100. Okay. So increases the depth. Now if d is equal to 0, then we need to oops. Okay, and okay, that should do it. There are just a bunch of special cases, but they're not really that hard. Okay. Okay, let's try some more interesting cases. That looks pretty good. That looks pretty good. Cool. Now what if it's unbalanced? Yes. Actually, I think I actually didn't even need to do part of this. I don't think they give me unbalanced strings, but regardless. I don't think, like, I think just making things balanced in a minimal length, with a minimal length string, I think that's not hard. I think that's basically what I'm doing. So, yeah, like basically this is what you can do to make it balanced in a, well, and this. In the simplest possible way. But of course, because I'm going to be unbalancing the string by doing stuff like this, and by doing stuff like this, so I have to balance it up. But anyway, let's submit it. I'm pretty sure this is going to be correct. I haven't proved anything, of course, but I might have missed a special case. So let's see. Test set. Okay. Oh, this isn't a hidden? Oh, they're both visible. Oh, okay. Well, whatever. Moving on then. I thought the second one was going to be hidden. They are going to give me some hidden ones, right? When it's hidden, you have to be a little more careful, of course. All right. Moving on. Parenting partnering returns. I don't remember what the original parenting partnering was. And they're both visible verdict, so whatever. Okay. Are they sorted? They are not sorted. Okay, so matching up. Well, this is a fairly textbook, like event-based solution. Like you're going to sort all the starting and ending times, and then you're going to keep track of how many intervals are open at a particular time. And if two are open at a particular time, then you're screwed. If they're not, then you can just assign. Like somebody will not be busy, so you can just assign them to it. And then you just have to match them up to the original intervals, which will be a bit of code since it's not sorted initially. Shouldn't be too bad. And let's see. I actually thought that they were going to ask for a schedule that was balanced, like where Jamie and Cameron, do say roughly the same number of activities or the same total time of activities, but they're not asking for that. So you just have to output anything that works, which is pretty simple, really. I mean, these first three problems. I mean, these are the problems that they just want you to solve so that you can get into the Google Code Jam. So they are not hard at all. Okay, parenting. I'll just maintain some pairs. Yeah. I think I need three things. I need when, I need the time at which the event happens, and then I need whether it ends or opens an event, and I also need the original number. So let's do 3. So if I put, okay, well, obviously the time has to be first because I'm going to sort by that. And I also want ending events to happen before starting events. That is kind of important. It's kind of a trick that you pick up as you do these problems. So the way to do that is just to represent like an ending event by like -1 and then a starting event by 1. So, and then just do that. And Yeah. So this is how you make sure that if an interval ends exactly when another interval starts, then you correctly track that those two intervals don't interfere. Whereas if you swapped the start and end events, you would think that one of the intervals was still open when you started the other interval. And so, I mean, there are other ways to deal with this, but this is the easiest, in my opinion. Another way is to handle all events at a particular time at the same time. And with more complicated problems, you might have to do it that way. But for something like this, where you're just tracking open and close intervals, just do it this way. Okay. Anyway, hopefully somebody who's watching this learned something from watching me for 3 hours, code for 3 hours. I kind of hope you're not just wasting your time. Anyway, where was I? Yeah, so we're going to... okay, so let's see. That should be fine. Okay. So this is going to put all of the work on C whenever possible. This is a very highly biased solution. I kind of I've always liked the marriage algorithm, because that is another algorithm where you can bias it completely in favor of all the men. You can get the optimal solution for all the men, or you can get the optimal solution for all the women, just depending on which side you decide to do first. So this is another one. I'm getting the optimal solution for C instead of the optimal solution for J. poor C. Yeah. Okay. So oops. And we're done, I think. Oh, did you have to track impossibility? Okay. You might notice that I just have I have a little utility I wrote that just adds all of my include files automatically, since C++ is annoying with include files. Of course, if I was using a real IDE, this would do it all for me. I've never really... I've always wondered whether I should just bite the bullet and learn to use an IDE for programming contests, but I never have. I assume it would be easier to debug, but if you're skilled, you've got good ways of debugging anyway, just with output. Not perfect. I think you probably still would be able to do a better job with an IDE, but anyway, I use VI, so whatever. Okay, it's not letting me in place back like this. Oh, I guess just... Okay. CJC, impossible. JC, does it find a swap? C and J. Wait. Oops. No, I can't just pick which one I want to make not busy. I have to check which one is actually. Yeah. Okay. Glad the tests caught that. That was silly. Okay, JCCJJ, that looks good. And CC and impossible. All right, let's give it a try. Oops. And I don't need to be particularly careful because, again, there's no hidden input. A nice crutch that is going to go away soon. That is going to go away as soon as we get to the real contest. So let's see if I screwed this up. Boom, boom. Nope. Hooray. What is this? Oh, is that just to... Oh, I see. That's to let me see what source code I submitted. I really don't like this interface. Anyway. Okay, well, that's the easy 3 done, and now it looks like there are going to be some tough ones. So obviously, I don't have to bother with these. Contestants with a final score of 30 points, and I've got 42 points already, so yeah, I've advanced. But they tend to put these problems in. They usually put the problems into the qualifying round because they're in some way inappropriate for a later round. Perhaps they're unfair in a particular way, or they do, or sometimes they feel they're too hard for a regular round. So so you never quite know what you're going to get with these bonus qualification round problems, but we'll find out. Okay, ESAB-ATAD. What a weird name. Oh, database backwards. I see. Oh, this was a distributed code jam problem? Okay. So they've taken the title and they reversed it, and they also swapped the case. So they're doing these two effects. Interesting. Okay, so this is the reason this problem is here, because it's an interactive problem. And I guess they're trying to introduce us to how interactive problems work. happens on the very first query. That's just annoying. And like it basically means throw away the first query. The interactive runner was changed. Okay, so this is going to be a good education on how to run an interactive testing script on their system. So, okay, so for the hardest test case, you you basically need to average 1.5 queries per character, which seems doable. I mean, especially since it only changes every 10. So what you're going to do is you're going to pair your queries. You're going to query the first and the last element of a of the string, so you'll know whether they're the same. You'll throw away the first query because that's not going to work. But then after this first query, you'll have 10 queries. You can query first and last, second last, third and third last, and so on. And so then you will know how they are related. And it may be that they're always the same. So the first is always the same as the last. The second is always the same as the second last, and so on. In which case you, well, if that continues forever, then the string is a palindrome and it doesn't matter. But as soon as you find a difference, then from then on you'll need to keep track of. So after every swap, after every quantum perturbation, you're going to have to query one of the bits you already know. Actually, you're going to have to query two of the bits you already know in order to figure out whether it has reversed and whether it has actually. Oh, it's a bit more complicated than that. Sorry. So you could have that the string is a sort of inverted palindrome. Like if you invert it, and reverse it, then you get the same string back. In which case, so that could also continue through the whole string. And in that case, again, it's not going to matter whether that element of the group will be indistinguishable from the identity of operations, if that makes any sense. So yeah, as soon as you get a combination of mismatched bits and matched bits, that's when things matter. That's when you're going to have to query a mismatched bit and a matched bit in order to figure out exactly which of the four states you're in order to continue queries. But up until that point, you won't know, and it won't matter. So anyway, so that makes the code a bit complicated. Not in terms of not programmatically, but in terms of like mental complexity. Because you're going to have to sort of handle the case that you're going to have to handle three cases. The case where everything matches, the case where everything doesn't match, and then finally the case where it's mixed. And that should get, so you're going to be querying, on average, you're going to spend 2 queries out of every 10 figuring out what state the string is in. So that's going to be, you're not going to use 150 queries for b equals 100. You're going to use maybe 120, maybe a little more. Okay. So okay. So most of the difficulty of this problem is actually going to be just figuring out how to work with the interactive program, which is why they're putting this in the qualification round. This is obviously going to be practice for some later problems. So bear with me while I try to figure this out. It's been a year since the last time I did this. Does it actually tell me B? Yeah, it does. Okay. Oh, actually, I guess it's not annoying that the first query scrambles things. I think that's exactly what we want. So I don't have to throw out the first query. Okay, perfect. Okay. So I'll keep track of which one matched and which one didn't match. And then B is always even, fortunately. Okay. So that flushes the output. Endl flushes the output, which is important. And okay, now if we've now made a multiple of 10 queries, sorry, equals 2, then I need to I'll just keep track of the last match and the last mismatch. And now I'm going to query 1 bit from the last match and 1 bit from the last mismatch. These are just my possibilities. Okay. Um, okay, and okay, that should do it. And you don't need to query the. You only need to query one of the two. You don't need to query. Say if you know that they match before at the beginning and the end, you don't need to query them both again because they're always going to be the same. They might be 0 or 1, but they're always going to be the same. And if they mismatched again, they're always going to mismatch, regardless of the operations. But depending on the combination of the mismatches and the matches, one of these 4 strings might be right. Or if you only have matches or you only have mismatches, then 2 of these strings will be right. So anyway, that should do it, I think. Now, yeah, whatever. Obviously, I'm not gonna bother handling the case where I get n. Well, I guess just so I get a wrong answer instead of a time limit exceeded, I need to do that. But it's a bit weird, but whatever, it's fine. Okay, so this should be a solution in theory. Like I said, the code isn't complex, but conceptually it's a little bit, you sort of have to justify to yourself why this works. And anyway. Yay, compiled. So that means it works, right? I could just try it by hand. So let's try 4. So it'll try 1, 1, 1, 1. Yep. Okay, so that's too easy. One. Oops. Okay, 1. Okay, now let's say it just swapped, or it's about to swap. So let's see, it asked me for 4 again, and 0. Yeah, that's right. That is not correct. Okay. Did I mess this up somehow? I kept on responding 1 up until the swap. At which point I responded 0, which should have told it that it flipped, but it didn't flip. Oops. Yeah. That shouldn't matter though. Yeah, that shouldn't cause this bug. Yeah, I'm a little worried here. Okay, 1. Okay, now it asks me again, and I say that it's flipped. Okay, why isn't this working? Oh, I guess these should be characters. Okay, little bit of a minor bug, just because it's comparing the integer 1 with the character 1, which obviously doesn't work. So okay, now it asks me for that again, and I tell it it's swapped. Okay, so it correctly figures out that the string has reversed. So let's try. Oh, oops. Okay. 1 0 1 0 1 0 1 0 1 0. Now suppose it's flipped. So zero, 0. Okay, so it correctly flipped the string. I am going to do a few queries that aren't necessary if B hits 100, but that's okay. I'm not trying to optimize for queries. This is going to be well under 150. So yeah, I don't actually need to do these queries if I'm at the end of the array, but that's fine. I'm not going to complicate the code by handling that case. Okay, now let's try to figure out how to run their interactive runner. Hope I have Python correctly configured. So looks like this just, okay, this just does a random bit string. So it's not going to test the interesting cases, but that's all right. I wouldn't expect it to. I would expect their judge to test the interesting cases, specifically when it's a palindrome or a reversed palindrome. Inverted palindrome. Yeah. Okay, so let's see if I copy this. So is this going to work? So I do Python interactive runner.py Python. Input position is out of range. Oh. Is it 1 through B? Oh, yeah. Okay. Well, that's good to know. This is why it's important to actually test using their tools. What the heck? Oh. Oops. Okay, why? So is that right? Judge return code is 0. Solution return code is 0. I mean, when it didn't work, God, yay, C++ errors. Oh my God, this is hilarious. Okay, when it didn't work, yeah, okay. I think this is what I want, the 2 finished. Oops. Now, if I add, just for the heck of it, suppose I add Tldr. Does that work? This will be useful later. Yes. Wait, why does it? Oh, it's prefixing. Interesting. So it actually tells me what the solution output prefixed with sol. Well, that's kind of cute. Okay, so I can put debug output in there, and then I will be able to see it. And I can see that it's running on many cases. Okay, so that's helpful. And looks like I've successfully run their tool for the interactive problem. So anyway, I think I got the solution, and we will actually, just for shits and giggles, I kind of want to know how many queries. I think it's going to use 120, probably 122 queries. So let's see. $124. Really? I'm not sure why it's using 124 rather than 122, but that's okay. Still well within range. Okay. Let us submit. So most of that was just getting the interactive thing to work, but that's good. That's what you want to do in the qualification round, right? Much better spending time in the qualification round than in a timed round. So now, notably, that random judge is not going to catch it if you mess up the palindrome or reverse palindrome cases. But actually, I think even if you forget about those cases, your code might work anyway. Not actually sure. You'd probably screw up those cases in a way that it worked anyway. Yeah. Anyway, I'm fairly sure I handled the cases correctly. Okay, so test set's passed, and I know that I don't use more than 150 queries, which is basically the only way I would fail the hidden test case. So, yep, I am pretty confident in the hidden verdict. By the way, do they specifically say that the judge only works with random? I don't think they tell us. The array, oh, okay. They specifically tell us the array is not necessarily chosen at random. And obviously they're going to give us some palindromes, and they're going to give us some inverse palindromes. So, yeah. Which is smart of them, and that's how you should test this. Okay. So that was kind of fun. I mean, not a very hard problem, but it's fun to think through interactive problems because they're a little different than the normal programming problems. Even the simple ones, you still have to sort of think in a slightly new way. Okay, so there's only one problem left. This problem is going to be a doozy, I imagine. Well, actually, it's got a fair 8% have solved it. Okay, maybe it's not going to be that hard. You can see I've started pretty far into the contest, so yeah. Ooh, he solved the entire contest. Xiao Wu solved the entire contest in under an hour. Under an hour total penalty time. That's really good. Actually, I've been out of it. I'm out of the contest community, so I think I recognize him because I think I competed against him at the Google Code Jam, and oh man, oh Snook, I know him. But yeah, there aren't too many names I recognize, unfortunately. Igor, he's a at the ICPC finals. He is a what do they call them? He's one of the commentators on the ICPC finals live stream. And of course, heavily involved with the community other than that. Anyway, okay, let's do this. Final problem. Indicium. Indicium means trace in Latin. Okay, cute. That's a callback. Ah. Interesting. So this problem is a generate an interesting thing problem. It is asking you to generate an object that satisfies certain criteria. And so you can do that however you want, but obviously you're going to have to understand how that's possible in order to solve the problem well. So, okay, unlike the other problems, I don't immediately see how to solve this. So n is up to 50. Now, if the trace is divisible by n, then the solution is trivial. You just do a diagonal square like this. If it's not divisible by n, so you can take any natural Latin square and you can permute the rows or columns. However, I note that if you start with a square like this, like just a diagonal square, and you permute and you swap any two columns or any two rows, you're ending up with the same trace. So one thing I could do is just try to generate Latin squares at random, although I'm not even sure how to do that nicely. But I could try to generate Latin squares at random and then see what their traces are. And in fact, you only need to generate one example for each trace. Although, okay, there could be up to like 2,500 different trace possibilities. So actually, yeah, that's you can't just pre-compute the answers because that's a lot of matrices. Now, okay, row and column transpositions, they don't do anything for the normal diagonal Latin square, but they might do something for non-trivial Latin squares. Let's see if I can even write down a non-trivial Latin square. Actually, so I can do something tricky. I can factor it. I don't know if you can see this. So for n equals 4, you can divide it into 2 by 2 submatrices. And so you can end up with a trace that is 1 plus 1 and 2 plus 2. And using this will get you anything you want, right? Yeah, I want to say for any even n. For any even n, you just divide it into n over 2 by n over 2, 2 by 2 matrices. And then you can swap 1 and 2 in a submatrix to get. So obviously you can go from n to n plus 2 by swapping one matrix, and then to n plus 4 by swapping another matrix, and so on, up until they're all 2s, at which point instead you generate a matrix that's 2s and 3s, and then you swap the 2s with the 3s to get 2n plus 2, and you swap another matrix to get 2n plus 4, and so on. So that gets you every even value. Can you have an odd value? Huh. What is forcing the trace to be even, if anything? Linear algebra is not my strong point. I don't know much about traces. I mean, I know that the trace multiplies out when you multiply matrices, and you know, the trace is what do you call it? Like it's a linear functional on matrices, something like that. It's one of the only linear functionals, something like that. I'm using the wrong terminology, but yeah, but I don't actually know how to use that for this problem because I don't really know. I mean, like I guess linear algebra doesn't really deal with these natural Latin squares. I don't know how to characterize these natural Latin squares. Yes, clearly you can have an odd trace. Like for n equals 6, you can just do my trick with 3 by 3 matrices, and then you can get n plus 3. Okay, so I've solved the case where n is even and the trace is even. That's a quarter of the case is done. Woohoo! Now I'm not even sure how to generate. Suppose I want to just generate a random 50 by 50 Latin square, one that is not just a simple diagonal. I'm not sure how to do that. If you just do a normal branch, well, like depth first search, you are probably going to get into trouble and not be able to finish the final rows. I mean, I guess I could whip it up quickly and see if that works. So here's the thing. If I can get a nice pre-computed matrix that has an interesting trace, like say a 50 by 50 matrix that has an interesting trace, I can swap the values in that matrix. So for instance, I can take all instances of 1 and I can replace them with 3s and vice versa. And that doesn't change the fact that it's a natural Latin square, but it will change the trace. And as long as there are sufficiently interesting values along the trace, I can probably use that to generate whatever the hell I want. So if I can generate a Latin square that is interesting enough, then I'm good. Okay. So I could just try generating that randomly, see how it gets me, how far it gets me. Yeah, why not? Don't have anything better to code up right now. Indicium. Yeah, let's try it with a smaller matrix. I mean, I'm just going to do this the stupidest possible way. Actually, no. Let's do it slightly more interestingly. I'll just do it from 0 to n-1, slightly easier. So 50 isn't really a problem. It's something like 47, which is going to be a problem. Since it's a prime number, I can't factorize it into submatrices, so I can't immediately see how to do the solution. So let's see if this actually works. Oops. What? Oh. No, that's no good. Ugh. That's not working. I don't immediately see what I'm doing wrong here. The heck? Well, you get to see my first instance of actual debugging. Huh. Oops. That's embarrassing. Ugh. I shadowed a variable. All right. So this did indeed work to generate interesting 10 by 10 matrices, and it looks like with a trace like that, I can do almost anything I want. Now the question is it going to scale? It is. Okay. Let me just adjust that. Oops. Okay, so it got into a hole at this point. So sometimes it gets into a hole, sometimes it doesn't. Interesting. So I've got a trace, I've got an odd trace, I've got an even trace. Now I think I'm still gonna have trouble doing a trace of, say, 49 for a 47 by 47 matrix. Now you can't do a trace of 48 because that would require all ones except a 2 on the diagonal, and that just doesn't work. But you should be able to do 49, which is going to be tricky. So this solution actually gets me a lot of the middle numbers, but it doesn't get me that. So is this ever going to succeed in generating a 50 by 50 matrix? I might need to put in code that tries a few times and then restarts if it fails. Yeah, seems like 50 by 50 is too much. Now, of course, I can generate a 50 by 50 just by dividing it, subdividing it into 2 by 2 matrices. But this doesn't help for 47. This isn't really a general solution. I'm still not seeing how to do a general solution here. I mean, the form of a general solution might be, okay, here are the values I want along the trace. I pick values that will work, and then I generate a matrix around it somehow, if that's possible. So if I can figure out a good way to generate matrices based on a pre-existing diagonal, then that might be all I need. Well, let's see. Let's try a different way of generating these matrices. So I can keep track of I can track across the whole matrix how many values have been fixed already. And then can I think of this as a bipartite matching problem? Where when I try to place a value, I end up following some links until I get to a free space. So if I can slightly backtrack, if I can try to place a number and then manipulate a few other numbers out of place to make it fit, maybe the DFS is guaranteed to work. I don't know how to prove that this could work. All this dead air is just because I'm trying to reason out how likely this solution is to work. It seems very, very iffy, but generating Latin squares is, I think it's an iffy enough procedure that it might not matter. Like this might be just a correct way to generate them. Because yeah, so as long as I don't get into a situation where it's impossible to continue, as long as with a little bit of work the algorithm can continue and complete the natural Latin square, then you're okay. But it's just a question of what heuristics will allow it to always finish. So for instance, if you can do a bipartite match sort of thing where you place a number and then you go up to where that number was previously in the column and you swap you you look in its row and you swap it with another number in its row, and then maybe that causes another conflict, so you swap that with another number in the column, and so on, alternating row and columns until something works. I don't know. Maybe I'm going about this the wrong way. Maybe I should be starting with the dumb diagonal Latin square and then just doing operations on it. I discarded that too quickly. Trying to see if I can even do a trace of 7 on a 5x5 matrix. Yeah, I can. I just filled in the 1s and 2s first and then made the rest of it fit. Now you can't do it on a 3x3 matrix. On a 3x3 matrix, a trace of 5 is impossible because 1, 1, 2 is not going to work, and 1, 2, 2 is not going to work. Or sorry, 1, 2, 2 is not going to work, and 1, 1, 3 is not going to work. Is this solution just going to be a bunch of special cases? I really hope not. Sorry, this is interesting just watching me write, but this is a tricky problem. Or at least, like, I think it's hard, but it might actually be easy, and I'm just missing a simple solution. It's kind of either you see it or you don't kind of problem, I guess. So here's a question. Starting from the standard 5x5 matrix, can I permute only the 1s, 2s, and 5s to make a trace of 7? So the 3s and the 4s are fixed. Is this going to work? No, it does not work. I reach a logical contradiction fairly quickly. Okay. But maybe if I just remove say 4 of the numbers, maybe that's sufficient flexibility that I can fill in the rest. So that one did work out. I was able to fill in a Latin square, keeping the 3s in the same position. So maybe just a dumb DFS on the positions of, say, 4 of the numbers can work. Maybe there's enough flexibility. Okay. Let's try some actual coding. Okay, so now I can try filling in a lot of the matrix and then see whether I can fill in the rest. So can say I want to trace a 52 out of 50. Okay, so that failed. What the? Okay, that's not good. Oops. Because that looks right, but unfortunately the search failed. So let's see, this is what I did with 5. I just placed wait, that's broken. That's not what I want. So yes, I was able to fill that in for a trace of 7. I was able to fill that in. I was able to fill that in. Okay. I was not able to fill that in. So I need to give it a little more flexibility, I guess. It's actually completely searching the space, which is why it's returning. How is it searching the space so quickly? Do I have a bug? Well, this should be like that. I'm kind of shocked how quickly it's searching through the space. I must be doing something wrong. This is never making it to 10. Why? It's never making it to 2. Okay, so that's a problem. There's definitely a bug here. Because it's never making it to 1. I should be able to just place this first row without any problems. Just has to place a 1 there. Oh. Do I have an overflow problem here? Yeah, it's an overflow. Whoops. Yeah, that was dumb. Okay, so that actually works. That works. What is the time limit for this? 20 seconds per test set. And There are 100 cases. Okay. Well, this isn't efficient, but it seems to run fast enough, so I just need to make sure I don't fill the trace with an impossible diagonal when there is a possible diagonal that I could fill it with. So for instance, I don't want to fill it with all 2s and a 3. But I could put in say, all 2s, a couple of 1s, and a 3. Or, sorry, a 1 and 2 3s, which might be more flexible. So this is good. I'm a little worried about not being able to return something that is possible. But if I'm careful, it looks like this very quickly is able to fill out a candidate. And I think it should be able to quickly tell me a candidate doesn't work as well. So I think we'll just find that out. Yep. Oops. Okay, so that does work. That works. Okay, I'm fairly sure that in most general cases this is going to work. Now, a lot of the special cases are in the first 5, so actually test set 1 is going to be helpful. Okay. Oh, they've already guaranteed that. So actually I'm good. Okay, now we have the special condition. We don't, if k% n is equal to 1, then we don't want to do this. We want to what am I doing? Is this right? So if n is equal to 2, if n is equal to 2, then 3 is not possible. So it doesn't even matter. Okay, and the other case is symmetrically still n is greater than 2. Actually, this has to be -1. Minus 2 minus 2 is equal to base. Shoot, can I have a case like that? Okay. Okay, there's a prospective solution. So that worked. 3, 7 is impossible because 2, 2, 3 doesn't work, and 3, 3, 1 doesn't work. Same reason, that works. That works. Okay. Cool. Is that the exception I wanted? Wait, 4, 6 is. Yeah, so that's easy. So that exception, that works out. Okay, so everything's possible except for 15 and 5, which we know are impossible. So, good. Oh, forgot to actually fill in the rest of it. So That's just to make it run in time. Shoot, still doesn't run in time. The heck? Oh. Impossible. What? Ugh. Oops. Okay. That's possible. Impossible. And it gets that right away, so that's good. That's not good. Okay, so I might have to include one more. Huh. Okay. So I probably don't need this one. I'm really just fishing around for something that works, but it seems to work. What's going on here? Okay. So what is it trying to fill in that's impossible? Well, I don't like that. Oops, that's out of range. Okay. Okay, so that's not good. At least it is going pretty quickly. Which set do I have to pick for it to work? I'm so close. Since this search does seem to work, it's just I have to pick the right set of things to not fix. Oh, okay. I see the problem. I want to rotate this based on the base. That's the problem. Yeah, so if n is equal to the base, it'll be on the diagonal. That's the issue that I had. Okay. That looks right. It is nice and fast. I think we have a solution, ladies and gentlemen. I mean, obviously it could be a lot faster, but it's fast enough for the purposes of this problem. And really, to prevent it from searching through the whole space, I might as well just shortcut that. Okay. So let me just try n equals 50. Well, n equals 47, just to make sure. All right, it seems pretty good. Yeah, it was. I should have realized something was off, that I couldn't just shift things by n. You couldn't just shift the numbers by n and have it still work. Okay, well, this has been kind of a poor solution, but I think we're good now. Restore the output. Oh. Shit. That's taking too long. Thought I had a solution, but this is taking too long. Well, dang it. Huh. I'm so close. Solving this problem is a tricky balance between making sure that the search works, like it won't fail, and making sure it runs in time. I thought I had the balance right, but it seems I do not. Gosh darn it. Okay. Now I already know I can't remove those. Yeah. I mean, I could rewrite the search so it does it picking the most constrained one first. Might have to do that. What? Look. All right, let's try that slightly improved search. Oh, I've got the same. Nope. Ugh. Is that right? Does that work? LL. Okay, so my bit count just doesn't work. 5053 impossible. God damn it. Should not be impossible. Why? That shouldn't have made something fail that worked before. That should have fixed it, if anything. What's going on here? Got some bug here. It's something to do with... No, it's not. Okay, there's just a plain bug. It's not to do with long longs. Funny, I thought I had this solved half an hour ago, but then it turned out to be running too slowly. Wait. Oh, yeah, that's right. Oh. Right. Subtle bug. I wasn't allowing backtracking. Still too slow. Mind you, my search is horribly inefficient. But with exponentials, that's not really the problem. I can try giving it a little more freedom, and that paradoxically might actually make it run faster. Actually, wait, I've already given it too much freedom, haven't I? Yeah, I don't think I want that. All right. Finally. I think we're finally good. Okay. Okay. Finally. This is a really ugly solution, I gotta say. submitting. Unfortunately, it did run really quickly with the optimizations. So I'm giving it enough latitude that is possible, and then I'm running a search that hones in on the most constrained sections first. And it failed. Uh-oh. Sample failed. Oh. I've yelled at students for like not checking the sample data carefully enough. But it can happen to any of us. Okay. It's nice that it tells you it fails the sample. Okay. Well, guess I'm done. That took me, wow, it took me like 2.5 hours for the last problem, or 2 hours. Anyway, I don't foresee a failure on the hidden data, but of course, it's tough to be sure. I mean, these are, I think the trickiest ones lie in this realm, but there are still, some tricky cases, and you never know. And it could run too long, but I don't think it's going to. I guess in theory, this random shuffle could screw me over, but it didn't seem to when I ran the tests. Anyway, it's fine. I look forward to seeing how the official solution is. I wonder if it's as horribly heuristic as this one, or if there is some nice principled way to generate these matrices, even in the case of like n being prime, like n equals 47. I don't know. So that's it for this stream. I guess if you're cooped up at home and you're watching this, then I hope it was edifying. I'm sorry that the last problem took me so long. And I will probably stream the later rounds in the Google Code Jam as well. So good luck to you in your Google Code Jam attempts.